Just weeks ago, we explored the mystery of 3I/Atlas, the colossal interstellar visitor racing through our solar system. Back then, speculation ran wild. Was it just a comet or something far stranger? Now, the story has changed. Fresh observations from Hubble and the Rubin Observatory have revealed jaw-dropping details about its size and activity. Even more astonishing, NASA is weighing a plan to send Juno on a daring intercept. In this video, we uncover the latest updates, and one burning question remains. Is humanity prepared for the truth it carries? The giant unveiled. It began quietly. July 1st, 2025. In the Chilean desert, the Atlas Survey telescope caught a faint, almost forgettable smudge of light. Nothing remarkable, nothing to raise alarms. But then came the orbit calculations, and the truth hit like a thunderclap. This object did not belong here. It had come from interstellar space. The third known traveler in human history, Oumuamua, Borisov, and now 3I/Atlas. At first, the excitement was simple, another visitor from the stars. But Hubble changed everything. Its cameras locked on and revealed a coma, a tail, and a nucleus that could be several kilometers wide, already bigger than anything we'd seen before. But then Rubin Observatory's measurements arrived. Not kilometers, miles, 7 miles across. A mountain of ice and rock larger than Everest, sailing in from the void. For astronomers, this was a revelation. For humanity, a shiver of awe, and the strangeness deepened. Normally, comets only awaken when the sun's heat begins to burn their icy cores. But NASA's TESS spacecraft, digging through its archives, found evidence of activity. When 3I/Atlas was still 6.4 astronomical units away, far beyond Jupiter's orbit. That distance is frozen territory where comets should be silent. Not this one. Swift Observatory confirmed the anomaly. Water vapor pouring out at 40 kilograms per second, even at $3.50. That's like 41-liter bottles of water gushing into space every single second from a body nearly 11 kilometers across. And it spins, a rotation period of 16 hours, slow enough for its jets to paint spirals in space, fast enough to keep its frozen layers breaking open. This was not just a comet. It was a puzzle, a time capsule, a messenger, an alien fragment drifting into our neighborhood carrying chemistry not of this world. And with every new observation, one thought began to creep into the conversation. What if there's something about it we still don't understand? Something we're not ready for? A cosmic debate ignites. On the surface, the evidence is clear. 3I/Atlas behaves like a comet. It vents gas, forms a coma, sheds dust, and spins on a predictable rotation. Photometry confirms it. Spectroscopy confirms it. Hydroxyl emissions scream water. These are the fingerprints of ice and dust. But then comes the unease. The details that don't quite fit. Its staggering size, larger than anything we've ever seen from interstellar space. Its strange alignment. Its orbit skimming the ecliptic plane like a native of our solar system. Its premature activity, already awake in the frozen deep where comets should sleep. For some, that unease is enough to open the door to radical speculation. Harvard astrophysicist Avi Loeb has argued that these anomalies, size, alignment, early activity, don't rule out the possibility of something engineered. A derelict probe, a shard of technology, a visitor not entirely natural. The idea is incendiary. Most scientists reject it outright. They point to the data, the hydroxyl signal, the color shifts in the coma, the measured dust production. These are not signs of propulsion or control. They are the messy, chaotic signatures of a comet. To the consensus, 3I/Atlas is natural. Exotic, yes, but natural. And yet the debate lingers. Because science isn't just about what we know, it's about what we can't explain. And 3I/Atlas refuses to sit neatly in our categories. Unlike Oumuamua, it lingers long enough to be studied. Unlike Borisov, it doesn't fade quickly into silence. This one gives us time. That time matters. In October 2025, it will sweep to perihelion at 1.36 astronomical unit. In December, it will cross Earth's orbit at a safe 1.8 astronomical unit, bright enough to observe again. And then in March 2026, it will skim past Jupiter at just 0.36 astronomical unit. Each milestone is a chance to gather data, to weigh the evidence, to decide whether this is just the largest comet we've ever seen, or a clue that interstellar space holds secrets stranger than we imagine. The debate isn't closing, it's widening. And with each day, the urgency builds. Because soon, this object will be gone, unless we find a way to meet it. Juno's impossible mission. Time. That is the enemy now. 3I/Atlas is on a one-way path. Past the Sun, past Earth, past Jupiter, and then gone. Lost to the dark. There will be no return. No second chance. If we want to see it up close, the moment is now. And there is only one spacecraft with a shot. Juno. Launched in 2011, Juno was built for Jupiter. It has spent years unraveling the giant's secrets, its storms, its magnetic fields, its auroras. Its mission has already surpassed expectations. But now, mission planners are considering a final, audacious chapter. Send Juno after 3I/Atlas. The plan rests on a knife's edge. To reach the comet, Juno would need to perform an Oberth maneuver, a slingshot around Jupiter, burning its engines at the precise moment of maximum velocity. Done right, the boost could fling it onto an intercept course. Done wrong, the chance is lost forever. The stakes? Historic. No spacecraft has ever met an interstellar object up close. Juno could change that. High-resolution images of a surface formed around another star. Dust grains, gases, jets, and chemistry never seen before. A direct look at alien material, untouched for billions of years. But the risks are daunting. Juno wasn't built for this. Its instruments are tuned for Jupiter, not comets. Its solar panels strain in the weak sunlight of Jupiter's orbit. Its fuel is finite, and every drop counts. The margin for error? Razor thin. And yet, this is the only shot we have. Building and launching a new probe would take years. By then, 3I/Atlas would be gone, a fading streak in the void. Only Juno is there. Only Juno can try. The image is cinematic. A lone spacecraft, built for one world, racing into the darkness to meet an intruder from the stars. The countdown has already begun. The decision rests with NASA. Do we take the leap? Or do we watch, from a distance, as the greatest interstellar visitor we've ever seen slips into the black, carrying its secrets with it? The opportunity of a lifetime. 3I/Atlas is not just another comet. It is a messenger from beyond, a relic of a star system we will never visit. Its icy core carries chemistry older than our sun, drifting into our reach for the briefest of moments. In October, it will blaze past the sun. In December, past Earth. In March, near Jupiter, where Juno may have the chance to greet it. Success could open a window into alien worlds. Failure would still mark humanity's boldest pursuit yet. Would you risk everything to chase it? Because if we don't, we may never get this chance again. Thanks for watching. We'd love to hear your thoughts in the comments. If you enjoyed this video, don't forget to like, share, and subscribe. Your support means the world and keeps our journey going.